So going along with rate of change, we can talk about estimates. So the derivative can actually tell us a lot about estimates of a function. How that's going to work is that lines are a lot easier to work with than curves. And the line that we've been dealing the most with is the tangent line. So basically we're going to use a tangent line to estimate at certain points. Okay? That's the idea behind it, is use the tangent line. Use the tangent line to estimate. And this is going to show up throughout the semester. Using the tangent line to estimate certain values is a lot easier than using the curve. So, let's do some examples of this. Let's say that a student determines that his grade, or determines that the grade he earns on a test can be computed by the equation f of t is t to the 3/2 plus 20. T is the time he studied in hours. Okay, and the first question that we're going to ask is how much is his score increasing? So how much is his score increasing at t equals 5 hours? Okay, so how much is his score increasing? That's saying what's the rate of change. So increasing, decreasing, those are all rates of change. And whenever we think of rate of change, we want to think derivative. So I'm saying, what is the derivative when t is equal to 5? Well, to answer that question, I need to find the derivative. Alright, so using the power rule, I can bring down my 3/2, so I'll get 3/2 t to the 1/2. The derivative of 20 is just 0, so I don't need to worry about that. Now, how much is his score increasing at t equals 5? That says what is f prime of 5, so I'll plug that in here. And I get about 3.35. Now what is this being measured in? Well, remember, the derivative was df dt. That's what we want to think. What is f being measured in? F is the score, so f is measured in points. And what is t measured in? T is measured in hours. So when studying at 5 hours, his score is increasing at 3.35 points per hour. That's what this is saying. Now in terms of words, what I would say is that at the moment where he's studying 5 hours, for each additional hour he studies, so that's the one on the bottom, his score will increase by 3.35 points. So in words, that's what's happening here. It's saying that for every additional hour, his score is going to go up by 3.35 points. Alright. Now how can we actually use this? Let's estimate his score if he studies 6 hours. Okay, so we know what f prime of 5 was. We found that f prime of 5 was 3.35 points per hour. Again, what this meant, and what you want to think in your head, is that, since this was over 1, for each additional hour of study, the score goes up by 3.35 points. So the score goes up by 3.35 points. So we're going to use that information to estimate what his score would be at 6 hours. So if we're going up by 3.35 points per hour, this means that at 6 hours, the score should be about, this is just all estimation, so it should be about 3.35 points higher than the score at 5 hours. Okay, so we're using the idea of the slope of the tangent line to estimate the score at 6 hours by using the score at 5 hours. Well, what is the score at 5 hours? The score at 5 hours would be f of 5, which is 5 to the 3/2 plus 20, which is 31.18. So we know that if he studies 5 hours, he's only going to get a 31.18 in terms of his points. I know that for each additional hour, that was the derivative, he's going to get about 3.35 points. That tells us that the score at 6 is going to be approximately the score at 5 plus the 3.35, which is 34.53 points. So what do we do here? We're estimating his score at 6 hours by using what we know about his score at 5 hours, because we did that in Part A. Part A told us that for each additional hour he studies, his point was going to go up by about 3.35. So his score at 6 is going to be his score at 5 plus that additional 3.35 points. This is using the tangent line. It doesn't look like we are, but what we're doing, kind of the idea behind it here, is that f of t probably looks something like this. Here was his score at 5. Instead of finding his score at 6, which would be this dot, we're finding the corresponding point on the tangent line. So this was our estimate. So what we did was we used the score at 5, added our slope of the tangent line, and that gave us a pretty good estimate as what the function is at 6. So that's what we're doing here. Now this is the picture you want to think, but in practice, we're going to find our function and then add to it the slope of the tangent line.